Astronomy is the scientific study of the universe beyond the Earth's atmosphere, such as stars, planets, and space, including comets, galaxies, moons, nebulae, the black holes, and supernova. We also study processes that govern the life cycles of these objects and phenomena that originate outside the atmosphere of Earth, including supernova explosion, gamma ray bursts, and cosmic background radiations. Astronomers use the electromagnetic radiations emitted from stars and other celestial objects, including visible light, ultraviolet, infrared, and X-rays, to study these celestial objects. Cosmology is related to astronomy, but it is a distinct subject that is concerned with the universe as a whole. The main branches of astronomy are astrometry, celestial mechanics, and astrophysics. Astrophysics, a branch of astronomy, is concerned with the physical processes associated with the celestial bodies and the intervening regions of space. Most ancient Greek astronomers believed that the Earth was the center of the solar system and the universe, with everything orbiting it. This is called a geocentric model, as shown here. Today we know that the Earth orbits the Sun, which is called a heliocentric model. Moreover, most ancient Greeks believed that all astronomical objects followed different physical laws and were perfect spheres and orbited in perfect circles around the Earth. However, Copernicus, Kepler, and Galileo disapproved these beliefs more than 1,000 years later. So this is the heliocentric model presented by Copernicus. He was the first astronomer to present this model, which is a major event in the history of science. Now, Kepler discovered that orbits of the planets are like ellipses and not circles. Kepler discovered that orbits of the planets around the Sun are shaped like ellipses and not circles. That is, they are like squashed circles. His work provided one of the foundations of Newton's theory of universal gravitation. Galileo built the first telescope in 1609 and discovered 4 largest moons of Jupiter and craters on the moon. He argued for the heliocentric model and said the Earth could be moving because of the law of inertia. Now, using the ideas of Copernicus, Galileo, and others, Newton created the 3 laws of motion and the law of universal gravitation. These laws accurately describe the motions of all objects everywhere, including astronomical objects. The solar system was formed 4.6 billion years ago. It consists of a central star, the Sun, the 8 planets orbiting the Sun, Mercury, Earth, Venus, Mars, Jupiter, Uranus, Neptune, Saturn, the dwarf planet Pluto, moons, asteroids, comet, meteors, interplanetary gas, dust, and all the space in between them. Now, this photograph taken from Lunar Orbiter 1 in 1966 is the world's first view of the Earth. And this photograph clearly shows that the ancient travelers had incorrect ideas about the shape of the Earth, that if it is flat and if they travel too far, they would fall over the edge. In fact, our explanation of the behavior of astronomical bodies are based upon the evidence we have before us today. Our present-day ideas and model may change in future and new evidence may be found. The solar system was formed 4.6 billion years ago. It consists of a central star, the Sun, the 8 planets orbiting the Sun, the dwarf planet like Pluto, moons, asteroids, comets, meteors, interplanetary gas, dust, and all the space in between them. The mass of the moon is 1.99 into 10 raised to the power 30 kilogram, and its diameter is 1,393,000 kilometers, or 1,393,000 kilometers. And temperature of its core is 15 million kelvins and surface temperature is 6000 Kelvin. So our sun is a huge ball of flaming gases and composition of each gas is different. Hydrogen is 71%, helium is 27.1%, and 1.9% is each of oxygen, carbon, nitrogen, neon, sulfur, magnesium, sodium, and iron. Now here the lunar phases are shown. It can be seen that these phases gradually change as the orbital positions of the moon around the earth and of the earth around the sun shift. Now here, this is a comet. It's the Grab Nebula, a remnant of a supernova explosion seen in 1054. It's the map of galaxy and superclusters filaments. Here I would like to distinguish between asteroids, meteorite, and some similar terms like meteor, meteoroid. So an asteroid is a small rocky object that orbits the sun. Asteroids are smaller than a planet but larger than meteoroids. When a meteoroid, a small piece of an asteroid or comet, burns up upon entering Earth's atmosphere, creating a streak of light in the sky, it is called a meteor. And as it lands the Earth, it is named as a meteorite. So I would like to describe a few more important terms we come across in astronomy. One is light year. 1 light year is the distance that a photon would travel in free space and infinitely far from any gravitational or magnetic field in 1 Julian year. That is 365.25 days of 86,400 seconds each. The speed of light is used by astronomers to measure distance since it is the fastest thing in the universe. They like to know how far things are in space. And please note that a light year is a unit of distance, not a unit of time. Second term is Milky Way. The Milky Way is a galaxy that contains our solar system. Its name describes galaxy's appearance from Earth, that is, a hazy band of light seen in the night sky, formed from stars that cannot be individually distinguished by the naked eye. And third one is galaxy. Galaxy is group of billions of stars that moves through space as a unit. And it is worth mentioning here that galaxies range in size from dwarf with just few hundred millions, like 10 raised to the power 8 stars, to giants with 100 trillion stars, that is 10 raised to the power 14. Galaxies are classified as elliptical, spiral, or irregular according to their visual morphology or appearance. Each speck of light is a galaxy. Some are as old as 13.2 billion years. The observable universe contains around 200 billion to 2 trillion galaxies. I have used the word observable as the total universe is much larger than the observable universe. Every day, the galaxies get farther apart from each other, and also new galaxies are being discovered. Scientists believe that there are more than 100 billion galaxies in the universe and have found a vast array of hidden or mysterious galaxies which were previously unknown.
Redshift. According to the wave and quantum theories of light respectively, redshift is a phenomena where electromagnetic radiations from an object undergo an increase in wavelength. This increase in wavelength is called redshift, which is equivalent to a decrease in frequency and photon energy h nu. Redshift and blue shift describe two light shifts towards shorter or longer wavelengths as objects in space such as stars or galaxies move closer or further away from us. The concept is key to charting the universe expansion. Redshift in light indicates that an object is moving away from the observer. This is called the Doppler shift or Doppler effect. The observed wavelength of light is longer and light is shifted towards the red end of the visible spectrum. This is one of the evidences that is used to support the Big Bang theory. It seems that the light traveling from distant stars is redshifted. That means the universe is expanding from an initial point to what we observe today, and all the objects are moving away. Further explanation of redshift. The apparent color of the light source is changed by its motion. For a light source moving towards an observer, the color of the light will appear bluer, while moving away from an observer, the light would appear redder. The effect claims that the observed frequency or wavelength of a light source depends on the velocity of the source relative to the observer. The motion of the source causes the waves in front of the source to be compressed and behind the source to be stretched.
Doppler effect is the shift in frequency and wavelength of waves due to the relative motion of the source and the receiver. There is an upward shift in frequency observed by the observer when the wave source is approaching and a downward shift when it is moving away from the observer. Doppler effect applies to all waves including sound, water, light, and all the electromagnetic waves. To better understand the Doppler effect, one must be familiar with the following terminologies. The distance between two successive crests in a sound wave or electromagnetic wave is called wavelength. See this wave. Distance between successive crests is one wavelength. Number of vibrations or oscillations per second is frequency. Wavelength is equal to velocity divided by frequency. Nodes are points where amplitude is 0 and antinodes are points where amplitude is maximum. An example of Doppler effect is the change of pitch observed when a vehicle surrounding a horn approaches and recedes from an observer. See, in this case, when the vehicle is approaching the observer, there is an increase in frequency, decrease in wavelength, and increase in pitch. See the difference. And when it is moving away from the observer, the apparent wavelength increases. This is better understood in this way. See, the vehicle is approaching towards the observer. So high frequency means high pitch and low frequency means low pitch. Explanation. When the source moves towards the observer, each successive wave crest is emitted from a position closer to the observer than the previous one. Hence, each wave takes slightly less time to reach the observer than the previous one. The time between the arrival of successive wave crests at the observer is reduced, causing an increase in frequency. When the source is moving away from the observer, the distance between successive wavefronts is increased, causing an increase in frequency. Hence, the waves spread out. Redshift. According to the wave and quantum theories of light, respectively, redshift is a phenomena where electromagnetic radiation from an object undergo an increase in wavelength. This increase in wavelength is called redshift, which is equivalent to a decrease in frequency and photon energy h nu. Redshift and blue shift describe two light shifts toward shorter or longer wavelengths as objects in space, such as stars or galaxies, move closer or further away from us. The concept is key to charting the universe expansion. A redshift in light indicates that the object is moving away from the observer. This is called the Doppler shift or Doppler effect. The observed wavelength of light is longer and the light is shifted toward the red end of the visible spectrum. This is one of the evidences that is used to support the Big Bang theory. It seems that the light traveling from distant galaxies is redshifted. That means the universe is expanding. from an initial point to what we observe today, and all the objects are moving away. Further explanation of redshift. The apparent color of the light source is changed by its motion. For a light source moving towards an observer, the color of the light will appear bluer, while moving away from an observer, the light would appear redder. The effect claims that the observed frequency or wavelength of a light source depends on the velocity of the source relative to the observer. The motion of the source causes the waves in front of the source to be compressed and behind the source to be stretched. The applications of Doppler effect. A few applications are listed below. Defining velocity of the speeding cars. Police uses Doppler effect of radar waves to measure the speed of car on the highway. To determine the depth of oceans by making use of sonars. In astronomy, to calculate speed of stars and galaxies. To study Saturn rings. Bats hunting for their prey. In medical diagnosis, to measure the rate and direction of blood flow in a patient's body with ultrasound. Meteorologists use Doppler effect to find out the direction and velocity of raindrops, wind direction, and other weather events to predict weather pattern, including coming storms, etc. Now we will solve some questions from the past papers from Cambridge board.